Second question, a wordy question. Before being packed in boxes, light bulbs in a factory have to be checked for working. Pass along a conveyor belt, checked automatically. 40 light bulbs arrive at random times with a constant rate of 1.9 per minute. Find the probability of at least one 40 bulb arriving in a 1 minute period. So we want the probability here that x is at least 1, if x is our random variable. And if x is our random variable, we'll say x follows a Poisson distribution with a rate of 1.9 a minute. So, x is greater than or equal to 1. How do you usually go about finding that? Greater than or equal to 1. We said in the last question, our tables are less than tables. What's greater than or equal to 1? Same as?
1 minus, less than or equal to 0.
Yeah, it's okay. It's always the same as 1 minus the probability at 0. Those two things there are identical. And that's not just for Poisson, that's for sort of anything. Okay? If it's at least 1, it's always 1 minus nothing. And they've done the 1 minus nothing bit here. Remember, in the Poisson, if you have x is 0, the formula simplifies just to e to the minus lambda. So that's what's happened here. They've simplified it to e to the minus lambda. That bit there is a probability of nothing. 1 minus it, they have their answer. So that's 3 marks for that part of the question. Part B is harder. In a period of t minutes, the probability of at least one 40 bulb is 0.004. Find the value of t. To start with here, if I know the probability of at least one 40 bulb is 0.004, what other probability do I also know? Using this sort of thing we did over here, what other probability do I know? James?
Probability equals 0.
Probability equals 0, which is everything other than this. What will that be then, James?
0.996.
Yeah, it would be 1 minus this one, because those are the opposite things. So it's useful to turn it around like that. So if we look at their solution here, we've said now it's a t-minute period. That means the mean, lambda, is going to be 1.9 times by t. It's 1.9 for every minute, so if it's 2 minutes, it would be 1.9 times by 2. If it was 10 minutes, it would be 1.9 times by 10. So for t minutes, they're calling it 1.9 times by t. They said if we know the probability it's greater than or equal to 1 is 0.004, then we know the probability at 0 is 0.996, following on from what James said a minute ago. And the probability at 0 is e to the minus lambda. We used that earlier on in the question. So e to the minus lambda, we said lambda here is 1.9t equals 0.996. Then you have to solve that equation. How do you go about solving that equation you've got there, where the lesser you're interested in is the power? Sorry? Using logs, the actual logs, yeah, that's right. And if you use the logs and you simplify it, you get this disgusting, horrible number down here. Okay, which was the correct, and then they're going to round it to 0. These questions, I think, are generated by sort of putting sort of random numbers in there. But there are 3 marks there, and there are another 3 marks here, which make that a 6-mark question. If you've got that number there, you've got all 6 marks, no questions asked.